Hi, welcome back to our statistics course. Now we will introduce the hypothesis test, second part. Today we will introduce the type 1 and type 2 errors. Why we need to introduce such errors? That's because for our hypothesis test, we usually base on some sample data, and then we may do some tests on it in order to know whether the statement for our hypothesis is true or not. So it sometimes may have some error happen. That means if we create a new hypothesis, but for our experiment we reject it, but the condition is the new hypothesis is true, then such conflicts we will say it is type 1 error. But sometimes we will find the condition is new hypothesis is false, but for our experiment or analysis we accept the new hypothesis, and such condition we will say it is type 2 error. Now let's look at such table. You will find in your population condition, you may build or create the new hypothesis and the alternative hypothesis. And you will know when the new hypothesis is true, and based on your experiment or your research analysis, you find your results also accept the new hypothesis. Then such both results they can be matched. So we will say it's a correct conclusion. But sometimes you will find the condition that is the new hypothesis is true, but based on your experiment, it will reject the new hypothesis. So for such both results cannot be matched, we will call it the type 1 error. And for another condition that is the new hypothesis is false, that means the alternative hypothesis is true. And based on your experiment or research analysis, you will find the new hypothesis can be accepted. So such conflict, we will say they are type 2 error. And then if you find the alternative hypothesis is true, and based on your experiment or research analysis, you find the new hypothesis can be rejected, then both results are matched, so they are correct conclusion. So here we can use an example to explain it again. It's an example from your textbook. That is the R&D team. They claim that the new automobile injection system, they have better energy efficiency performance than the current one. And they said the energy efficiency current one on average is 12 km per liter. So based on the development of the new hypothesis and the alternative hypothesis, we usually put the statement we would like to test as the alternative hypothesis. So here you think the new generation of the injection system may have better performance than the current one. So the mu for you as the performance for your injection system, you may want it has better performance than the original one. So we put it as the alternative hypothesis, that is mu larger than 12. So the new hypothesis would be the contrast to the alternative hypothesis. So is mu that is less or equal to the 12 kilometer per liter. So in such example, you will find the population condition if the mu hypothesis is true, and the conclusion you find that the new hypothesis can be accepted, then they are correct conclusion. But sometimes you will find the condition is new hypothesis is true, but based on your experiment or analysis result, you have to reject the new hypothesis. So such conflict we will say is type 1 error. So when the new hypothesis we find it is false, that means the alternative hypothesis is true. And the conclusion you find based on your experiment you find, you have to accept the new hypothesis. Such performance cannot be matched. We call they are type 2 error. If the condition can be matched, that is, the new hypothesis is false or the alternative hypothesis is true, and based on your experiment or analysis results, the conclusion is you can reject the new hypothesis, then we will call it the correct conclusion. So you can base on the true condition for the population and your experiment conclusion to find if they are matched or not for your conclusion as correct or in type 1 or type 2 error. So the probability of making a type 1 error when the new hypothesis is true as an equality, then we will call it the level of significance, and usually use the Greek symbol alpha on behalf of it. And in order to test such hypothesis, we will choose it on the level of 0.05, 0.01, or larger, that is 0.1. So by selecting the alpha, the person will control the probability of making a type 1 error. So if we use such a way to do the hypothesis test, we will also call it the significance test. And you may ask, why not use the type 2 error? Because type 2 error usually need to control many criteria. So it's much more difficult to say the true condition in compared with type 1 error. So statisticians and the analysis, they are more prefer use type 1 error for your hypothesis test. So sometimes they may avoid to say that they accept the new hypothesis in type 2 error, because there are too many conditions they need to control. So they prefer in such conditions they do not reject the new hypothesis. For example, for the type 2 error, that means if we say someone is a good guy or has guilty, the population condition for the type 2 error usually maybe the people is guilty, but your condition say he is a good guy, then you may need to find many proofs to say whether, or evidence to say such people is a good guy. But there are so many contexts or situations you need to control, so it's very difficult to explain or use such types of error in your hypothesis test. So that means the statisticians or the analysts, they prefer use type 1 error for the hypothesis test. So that's today we would like to introduce the type 1 and type 2 errors.